Greetings everybody. I am Dr. A. Radhakrishnan, Associate Professor in CSE Department, Sedu Institute of Technology. I am going to take a topic called projection in data science. So when we say projection, we are meaning dimensionality reduction. So for a data set, there are a number of attributes which are used in the data set. So the number may be very small to very large. When the number is so large, we have to reduce the dimension so that we can have faster computation, and we should also get the same result of the full data set. So here the concept is dimensionality reduction, where for example when there is a number represented by 8 cross 8 matrix, we can have 64 dimensions, and from that we can reduce the dimension to 8. So from 64 to 8, but the result should be the same as 64 numbers. So this is called dimensionality reduction, which is projection. So here we are going to see one method of dimensionality reduction, which is called principal component analysis. These are the steps in principal component analysis. The first step is on standardization. The attributes are continuous variables. We have to standardize. I'll just be talking about that, how we have to standardize that. Then we have to find the covariance matrix from the attributes. Then we have to compute the eigenvectors and values of the covariance matrix. Then the feature vector is created. Then we have to recast the features. Features are attributes. These are the 5 steps involved. We will see one by one what are the 5 steps. The first step is called, before that, each attribute contributing to the data science may be different. For example, the first attribute is contributing up to 40%, and the last one is about 2%. So in this example we can take the first 3, so that we get the result of the calculations very near to all the 10 attributes. So now we will be talking about standardization. So here, when we want to do the standardization, we want the largest possible variance. For that, this is the formula. Z equal to values. Value is the value of the attribute. So from each value of the attribute, we subtract the mean and divide the whole by standard deviation. So we will convert all the attributes to a standard form. That is why it is called standardization. So we will subtract the mean from the value, and we will divide the whole by standard deviation. So this is the next step, the covariance matrix computation. So here we have a 3 cross 3 matrix. That means we are having some 3 attributes. For example, attributes X, Y, and Z. So covariance has this formula. X bar is the mean. This is each variable. So it is summation of xi minus x bar whole into yi minus y bar divided by n minus 1. So this is the formula. So in the diagonal of the covariance matrix, we have the covariance between the variable and itself. So that is called variance. That is called variance. When we find the covariance for an attribute to itself, then it is called variance. So the diagonal elements will be the variance. It will always be a square matrix. So we have to find the covariance matrix. So next one is we have to find the eigenvectors and eigenvalues. So this is an example where the covariance matrix is having 2 cross 2 form. So here when we find the eigenvector and the eigenvalues for the covariance matrix, these are the eigenvalues lambda 1, lambda 2, and these are the vectors corresponding to that. So we have to form a feature vector. So this is by combining both we get this feature vector, and we have to see which column is the least. So in this we can see that the first column is the least. And we leave out the second column. So the last step, recasting the data along the principal component axis. So feature vector, previous. The first row is taken, so that will be the feature vector. Next. So this will be the feature vector transpose. Instead of having the feature vector in the column wise, we are having it in the row wise, and that is multiplied by the standardized original data set transpose to get the final data set. So this will have the reduction in the number of attributes. So this is called dimensionality reduction, and this is called projection in data sense. So these are the references which I have referred to take this topic. You can go through these references. Thank you very much. Thank you for your hearing. Thank you.